In this module, we'll build our first specialized block, which is the foundation for the level. That'll be the floor. The floor will be a child class of the BP base block and use the materials from the BP base block. It will also be unbreakable. Our objectives for this module are to write a sequence as part of a construction script. We'll create an instant static mesh with similar properties as a static mesh. We'll utilize a nested for loop or a loop inside of a loop. We'll use instance editable variables to control the size of the floor actor. To get started, find the BP base block blueprint in the Blueprints folder. Right-click on it and select Create Child Blueprint class. Name the new blueprint BP_floor. Open the new blueprint for editing. By creating a child class, our new class will inherit all of the attributes and data of its parent class as well as any functions, like the getAttached location. By using the object-oriented mechanism of inheritance, we can make use of the components and functionality of the parent class and specialize the child class in a way that makes sense for it. Let's make sure that the floor is not breakable. So we'll need to see our parent class's variables. In the My Blueprint panel, click the drop-down and select Show Inherited Variables. You can then open up the Variables panel, select the isBreakable value, and then uncheck the isBreakable value so it's false, and click Compile. Now we'll add the components that this class needs. Select the default scene root, click on the Add Component button, and search for Instanced Static Mesh. Name this Instanced Block Mesh. We'll use this block to dynamically create instances of the block used for the floor. This is much less expensive in terms of memory and rendering than if we use several instances of the same static mesh. We need to add two variables to control the size of the floor. Click the Add Variable button and name the first variable Floor Size X. In the Details panel, change the variable type to integer. Click Compile and set the default value to 20. The floor size Y will be the same as the floor size X in its default value, and it will also be an integer. Because of that, I'm just going to select the floor size X and click Ctrl W and change the name of the variable to floor size Y. Click the Compile button, and you'll see that the default value is also 20. Another change we'll make to the floor size X and the floor size Y is we'll make them instance editable. So in the Details panel, click on Instance Editable for floor size X, select floor size Y, and make that instance editable as well, and click Compile. That will expose the variables in the editor so that we can change the size of the floor in the editor rather than come back and modify the blueprint. And when we make multiple instances of the floor, we can make them with different sizes as well. We're now going to edit the construction script. Click on the Construction Script tab to open it. In the Construction Scripts graph, if you don't see a connection from the Construction Scripts entry node to the parent's construction script, right-click on the Construction Script node and select Add Call to Parent Function. Then link those two nodes up. This will call the parent's construction script. This is useful in the event the parent construction script has code that should be run before the child class is created. If you've used other object-oriented programming languages, such as Java, this is analogous to calling your superclass's constructor explicitly. Now, in this particular example, the parent's construction script doesn't do anything, but it might in the future, and you probably want to call it from all of the classes that inherit from it. The first bit of code we'll add will be to snap the actor location to a unit of 100. This will ensure our math works for the getAttached location function in the base block. Right-click and type getActorLocation and select the getActorLocation node. This returns the location of the actor in world space. Drag off of the return value and type in snap and select vector snap to grid. Set the grid size to 100. Drag off of the return value of the vector snap to grid and type in set actor location. Hook that up to the parent construction script. For this to work correctly, we need to make sure the construction script doesn't run when the actor is dragged in the level. Go to the class settings and under the blueprint options, uncheck Run Construction Script on Drag. Use a sequence node with 3 nodes to help organize the code. Press S on the keyboard and left-click to bring up a sequence node. We'll use 3 execution pins for our sequence node, so click the Add Pin button to add the 3rd one. Hook up the sequence node to the set actor location. On sequence wire 0, set the static mesh of the instant static mesh component to the same static mesh as the superclass. To do this, drag out the block mesh, drag out the instance static mesh, and drag off of the instance static mesh and type in set static mesh. To get the static mesh from the block mesh, drag off of the block mesh and type in static mesh and select get static mesh and hook up the return value of that to the new mesh. Also make sure you hook up the sequence for 0 to the set static mesh pin. We can now destroy the block mesh component because we won't be needing it anymore with this class. So drag out another block mesh, drag off of it, and type in destroy component, and hook that execution pin to the set static mesh pin. On sequence wire 1, we'll write the code to build the floor. We're going to use a nested for loop, which is a for loop inside of a for loop. Drag out of sequence 1 and type in for loop. The first index should be 0. The last index should be the floor size x minus 1. I'll explain in a minute. Drag out the floor size x and select Get Floor Size X. Drag off of the floor size x, type in a minus symbol, and select minus int, and use the default value of 1, and hook that up to the last index. The reason we're subtracting 1 from the floor x size is that the floor x size has a value of 20 by default, and the first index is 0. That's 21 numbers, 0 through 20. We want 20 for the entire number of blocks, so 0 through 19 would be 20 floor blocks. So we have to subtract 1 from the floor x size. To the person creating the level, it wouldn't make sense for them to specify 19 and get 20 floor blocks. So we do that math for them here in the construction script. We're going to use the index of the loop body to help us figure out where to put the block in the x-axis. So right-click on the index and select Promote to Local Variable. Local variables appear in a different location than blueprint variables, and they're local to the script that they're in. Name the new local variable x. Hook up the execution wire to the loop body. From that node, drag off the exec pin and type in for loop again. And for this for loop's last index, we'll use the floor size y. As a shortcut to getting a variable value, hold down the Control key and drag the variable out. Once again, reduce the value by 1, so type in a minus sign, int minus int. Use 1 for the value and hook that up to the last index. We'll promote the inner for loop's index to a variable as well. Right-click and select Promote to Local Variable and use the name y. Hook up that execution pin. All that's left to do is to add the instance of the instant static mesh and calculate where it should go. Drag out the instanced block mesh, drag off of the instance block mesh, and type in Add Instance. Hook that up to the Set Y execution pin. To create an instance, we need to have a transform, a location, a rotation, and a scale. We're only going to furnish the location. Right-click on the instance transform and select Split Struct Pin. We're going to calculate the X, Y, and Z, so we'll be setting them independently. Right-click on the instance transform location and select Split Struct Pin as well. This will give us access to all three of those values. The Z value will always be 50, as we're offsetting all of the blocks by 50 units to make up for the fact that the point of origin of the blocks is in the center of the block. Get the X from the local variables and the Y as well. These will hold the value 0 through whatever the last index is. We'll multiply that value by 100 because each block is 100 units cubed. So drag off of the X, type in a multiplication, and we're going to use int times float because the instance transform location is a float. This will convert the integer x to a float when we multiply it by a float, which is going to be 100. Duplicate this node, select it and press Ctrl W, and hook up the Y value. We have to offset these by 50, again, to account for the point of origin difference. So drag off of the product, type in plus, and select float plus float, and use 50 for the other value. Duplicate this node, Ctrl W, and hook in the product of the Y times 100. You can now directly connect the X value and the Y value. To check if this is working, click Compile, go into the viewport, and have a look at your 20 by 20 floor. Now that the floor is created, we have to adjust the box collision so it will cover the entire floor. In the construction script, drag out the box collision component. Drag off of the box collision and find the Set Box Extent node. Hook that up to sequence wire 2. I'm going to reposition the nodes a little bit to make it easier to do that. For the value of the box extent, right-click on it and select Split Struct Pin. This allows us to adjust the X, Y, and Z separately. We'll know that the Z is going to be 50. Recall that the box extent is a radius extending out from the center of the box. To calculate the X and the Y, we'll use the floor X size and the floor Y. So drag those out and get them. Again, holding down the Control key to do a get. And we'll multiply those times int times float by 50. I'm going to duplicate that node, Control W, hook up the floor size Y, and hook those up to the box extent. And that will cover the size of the box extent. Now observe that it is not in the correct location yet. We have to move it to the center. To do that, drag out another copy of the box collision component and type in set world location. To calculate the world location, we'll make a vector and we'll add the current actor location to that. So right-click and type in make vector. We'll use the calculated center point of the box collision. So the X goes into the X, the Y calculation goes into the Y, and Z is going to be 50. So this tells us the location in local space. Right-click, get actor location, and drag off of the make vector plus vector, and add the offset in local space to the current actor location and connect that to the new location. Make sure your code is compiled and saved, and then go back to the block game map. You can now drag an instance of the BP floor out and change its size using the default variable values. So for floor size X, we have 20. We can change that by clicking and typing a new value or dragging slowly. Don't go too crazy with the floor X size and the Y size yet. And you can also reposition and observe that when you reposition the floor, it is snapping to the grid units of 100 by 100. I'm going to lower that down in so it just rests right on top of this island. And it looks like I made the floor size Y just a little bit too wide. There we go. 23 looks pretty good, and 27 in the X. In this module, we wrote a construction script for the floor using a sequence and the nested for loop. We created an instant static mesh with similar properties as a static mesh. We applied instance editable variables to allow us to modify the floor in the editor.